Good afternoon. Welcome to this Midfix live event. As it's a live event and it's our first one, we just want to make sure that technically everything's working and you can hear the presentation and see the presentation. If I could ask you just to pop your name into the chat box above and send it through to us now. My colleagues will then tell me that everything is working okay. So we'll just wait for the confirmation. Thank you. Okay, everything seems to be working and you can hear me. So without further ado, we will go straight into the presentation. Today it should take about 45 minutes depending on questions to an hour, but it's on anchors and bracketry best practice. So the key question that we are concentrating on throughout this presentation is the questions that's on your screen now. If challenged, can you demonstrate that the fixings and supports you've installed can actually take the service load you've applied to it? And that is the key question. If challenged, can you demonstrate that the supports and fixings you've installed can take the service load? Has it gone through? Apologies. As it was our first live event, we've had our first technical glitch. Hopefully we're through all the glitches we're going to get. So the key question is on the screen. If challenged, can you demonstrate that the supports and fixings you've installed can take the service load applied to it? This question is often misunderstood by many contractors because the first thing they will say is, well, actually nothing I've installed has ever collapsed. And that may well be true. But the question's not asking that. It's, can you evidence, can you prove your installation? And unfortunately, many of us in our industry are in a position where we can't actually prove it. And it's a state that we all have to get to. We have to be able to prove both the fixing and the bracket can actually take the service load that we are applying to it. And this is the reason why, even though I've said before, most contractors will say that their bracketry hasn't collapsed. Unfortunately, we do tend failures on a regular basis, and they tend to be down to one common error. There's a couple of images on the screen there that most of you would have seen before. There's a school hall with a ductwork collapsed, a roofing collapse failure. Unfortunately, the image on the screen now was the Boston Big Dig. Following this particular incident in the States, anybody installing a resin had to be certified to install that resin. And we've started with the fixings for one particular good reason. Usually, the fixing in a support and bracketry is your weakest point. It's the interface between the load and the substrate. And it's the fixing, as stated, that is usually the weakest point. So we're going to start with a fixing. How do we evidence that the fixing we've just installed can take the service load? Well, thankfully, there is an answer for this, and it is under BS 8539. Came out in 2012. It covers many stakeholders. It covers people from the manufacturer of the anchor, the suppliers, the contractors, the installers, and the testers. We all have a part to play and some due diligence within the standards. There is also the TR50 document published by BESA, British Engineering Services Association. It's an excellent document and it breaks down BS 8539 into an easier to manage sizable document. It also covers best practice for bracketry as well, because clearly the bracketry that is connected to the anchor is carrying the same service load. So that needs to be evidenced as well. We've broken down BS 8539 into 4 hopefully manageable sections, because the one thing we need to do in our industry, keep things as simple as possible. The more complex we make a subject, the less chance of that actually being put through to the sites and actually working. So we've broken it down to 4 key areas. The selection process. How do we supply the anchor and the bracketry to site? The installation, and finally, if testing is required, how do we go about testing that particular fixing? So we're going to start with the selection process. If I can start just by highlighting, traditionally within M&E, the selection process is usually carried out by the individual on site carrying out the install, and they normally fall back on past experience. So they'll look at the application that they've got to install, and then they will typically order anchors that they've always used, knowing that those anchors have never let them down in the past. Unfortunately, that's not a selection process within M&E. If we look at other industries where the selection process is far more stringent, such as the civils, the selection process is done well before the installation process, usually at design. And the other key thing to remember on whoever picks that phone up or sends the email to order any anchors is they are classified as the specifier. And this is really important to keep in the back of your mind. Whoever the specifier is the first port of call should anything go wrong, or should the due diligence need to be investigated as to how that anchor was specified. So that specifier could be the installer, could be a procurement professional, could be the designer. It's a number of people, but if you've made the choice of anchors, you are the specifier. So the specifier's responsibility, they need to show some due diligence when selecting anchors. They need to understand the substrate that we are fixing to. After all, it's the substrate that is creating the resistance required to carry that load. They need to understand the loads that are being applied to the anchor. So often, if we're asked to specify an anchor, we will always ask for the applied load on that particular anchor. The specifier, and that's what we'll call them from now on, needs to understand the environment that the anchor is being asked to work in. The environment is very important, not just for the anchor, but for the bracketry and support systems underneath that particular anchor as well. The specifier needs to understand the installation type. I'll explain this in a slide a bit later. Very important, point 5, the specifier needs to understand how and why that anchor works in that particular substrate, because there's no such thing as one anchor for all loads and all substrates. So the specifier needs to understand that in some depth. And finally, the specifier needs to understand any approvals that are required, and what does BS 8539 tell us about approvals. So just touching on all of those points, BS 8539 only covers concrete and masonry and block of a certain density. It doesn't cover areas such as timber, steel, if you're looking at composite decking, for instance. But some of the principles within BS 8539 can actually be used to help us and give us guidance in things like cross-laminated timbers. But one of the key questions, and normally when we are fixing, we will be either fixing into either a concrete substrate or a composite decking material. But if it's a concrete substrate, the specifier has to understand the difference between cracked concrete and non-cracked concrete. And what does that actually mean? It's a question we always ask on site when we are carrying out some specification work, and usually the answer, is it cracked or non-cracked, is met with a shrug of the shoulders. I've no idea. Normally the structural engineer can tell us, but just to give you a brief as to what cracked concrete is, if we look at the image of the beam, so the top of the beam is somebody's floor, underneath the beam somebody's ceiling, and don't forget that is traditionally where a lot of M&E applications will be hung from. Concrete is a wonderful material. It's very, very good in compression, very poor in tension, hence the need for tension bars or reinforcing bars. But you'll see the beam is trying to deflect. The top of the beam is suffering from compression, not a problem normally in concrete. However, underneath, the bottom of the beam is actually in tension, which concrete is not very good at. And that's where you'll find most of the reinforcing bar at the bottom of the beam. So typically if we're fixing up into the ceiling, a lot of the time reinforcing bar is found anywhere between 20 mil and 30 mil, because that's where the concrete is trying to deflect. That's where it's under tension. That tension zone, it's probably a better term, is a cracked zone. And we have to select the correct anchors for that particular zone. Or should I say, the specifier needs to select the correct anchors for that zone. If we get it wrong and we select or specify an anchor that is not approved for cracked concrete, we could actually be losing up to 80% of the load carrying capacity of that anchor. Really important to remember. If we don't know, BS 8539 actually helps us and says if you don't know and you can't ascertain whether it's cracked or non-cracked, you assume it's cracked. So we'll always assume the worst case scenario. So number one, the substrate. We have to understand the substrate. The specifier has to understand the substrate. Number two, the loads. What load are we applying to the anchor? And the load is simply not 2 bits of 25mm copper and a bit of cable tray. It's an applied load, including any dynamics that could be added afterwards, such as cable pulling. We need to understand the loads that we will be applying to the bracketry, which in turn will transmit that load to the anchors. Very important and to understand. If it's tension, if it's shear, is it combined? We have to understand that. Again, the specifier has to understand that. The specifier also needs to take into consideration for both anchors and bracketry the environment that they're being asked to work in. Normally, we work in nice dry environments. However, if we remove the walls and we create something like a multi-storey car park, we've changed the environment, and therefore we need to look at the finish of both anchor and support bracketry. There are certain areas like tunnelling and swimming pools. So swimming pools suffer from chlorinated environments, which can be very aggressive to certain finishes. So the specifier needs a strong understanding of the corrosive classifications as to where they are working on. The types of installation, this is probably not so important for the specifier, but certainly important and needs to be kept in mind for the installation teams, because they will make the job easier or harder. The first type is a flush fix. A flush fix anchor is an anchor that needs to be pre-marked, pre-installed, and then the fixture can be offered over the top. It normally takes a little bit longer of an install because there is some setting out to be carried out with this type of anchor. The second type is a through fix anchor. As the name suggests, we can actually fix through the fixture straight into the substrate. And this normally makes, not all the time, but normally makes for a quicker install because marking out is not as critical. However, really important for the specifier to understand is how the anchor works. All anchors work on either one or a combination of three basic principles. They either work on friction, interlocking or bonding. And those three principles cover all anchor applications. And some of these principles, such as friction means it's an expanding type of anchor, whether it's a deformation controlled, commonly known as a drop-in or a wedge anchor, or a through bolt, which is a torque controlled expanding anchor. These types of anchors impose a huge stress into the substrate. Interlocking anchors, such as concrete screws, impose a much lower stress into the substrate. And resins are very similar to interlocking. Some resins work with a combination of bonding and interlocking, but they impose a smaller stress into the substrate. The stresses that we are imposing into the substrate create limitations. It means we can't place anchors very close together if they're a high stress anchor or near the edge of slabs. Anchors that impose a stress into the substrate, so expanding type anchors, and obviously other types of anchors, create a cone of influence, and we need to be careful that we don't position the anchors too close together. If you look at the data sheets, and everything about this is about data, if we look at the data sheets, the specifier should have these at hand, it will tell you the minimum distances from each anchor and from the edge. If we go too close, there are reduction factors to be applied by the specifier, and indeed there is a limit as to how close we can go. There's an example on the screen of something that's quite common, which is a breakout failure of that slab. You see this quite often where we have base plates particularly fixed down with through bolts, expanding type anchors, where there's 4 anchors far too close together. You know, we should be looking at, or the specifier should be looking at stressless types of anchors. They're not truly stressless, they do impose a stress into the substrate, but with regards to a concrete screw will put much less stress into the substrate than an expanding type anchor. So the specifier needs to understand the 3 basic principles, interlocking, friction and bonding, how they work and how they affect the substrate, because that will limit which anchor we can use in which application. The final bit of due diligence that the specifier needs to understand is the approvals. So what does BS 8539 tell us? Well, BS 8539 is quite clear on this. It tells us if an ETA approved anchor is available, it should be used. And an ETA is a European technical assessment. It's where the anchor manufacturer sends their anchors away for independent testing, but the testing is carried out, it's a harmonised set of standards. So we can actually compare like for like when we're looking at different anchor manufacturers. But for the specifier, the ETA sheet gives us the information required in order for us to understand the resistance that that anchor will give us in a known substrate. Without that information, it makes the specification process, I won't say impossible, but extremely difficult. So BS 8539, very straightforward. If an ETA anchor is available, it should be used. Now, there is a good reason why there is quite a few non-ETA approved anchors on the marketplace, and it's for commercial reasons, because the ETA process is an extremely expensive process. But without that data that the ETA data sheet gives you, it makes it, as I've said before, extremely hard to specify. So that's crucial. And that ETA data sheet is part of the evidence. So if we look at all the due diligence that's gone on there, that all forms part of the chain to evidence that the anchor is actually fit for purpose. The supply then is often where some of this due diligence can go wrong. So we've now changed our methodology. We've gone from waiting till we arrive on site, waiting till 3 o'clock in the afternoon, and then ordering the anchors for delivery next day. We've moved this process forward, or should I say back. We now are specifying the anchors well before the installation teams are on site. And there's a lot of hard work gone into it. There's some due diligence and there's some planning gone into it. We then need to make sure that that specified anchor is the anchor that actually reaches site. And it does go wrong at this state. So BS 8539 gives guidance to suppliers. So for instance, a supplier should be providing you with the exact anchor that you have ordered, and not one that looks similar, has the same description, and it happens to be an anchor that they have in stock. It needs to be the anchor that the specifier has specified, because all anchors from different manufacturers have slight variations behind them, even the ETA approved ones. So the anchor that's been specified has to be the one that reaches site. BS 8539 does give us a change management process should a change be required, but the change management process needs to be adhered to. And change management is not, I have this anchor in stock instead of the one that you've asked for, it has the same description. That's not change management. We need to go through all the due diligence that was required to specify the anchor in the first place, and the specifier needs to be kept informed. The other reason, if we look on the screen now, these are deformation control anchors. They go under another issue our industry suffers from is we tend to call one product by a plethora of different names. These are deformation control anchors, wedge anchors, red edge, drop-ins. They work by a displacement plunger, and they're a friction anchor, so they impose a lot of stress into the substrate. A very common anchor in the M&E industry, and a very good anchor if selected and installed correctly. But there's 8 on the screen. All 8 have different recommended loads. This actually highlights one area as to why anchors don't collapse on a daily basis. We've painted a very dire picture about anchor failures, but the truth is, yes, anchors themselves don't actually fail, but structures come down, so to say supports come down on a regular basis. It's usually because they have been installed incorrectly. However, if we look at the anchors that are on the screens, within M&E, our applied loads tend to be quite low. And if you look at the anchor that's highlighted there, one of them has a recommended load in excess of 3 kilonewtons, which is quite a hefty load. Most of our loads won't be anywhere near that. So even if this anchor is selected wrong and installed incorrectly, the chances are the anchor will still take that applied load because the safety factors are huge behind these anchors. 3.6 kilonewtons is a recommended load, not a failure load. The failure load is extremely high. So the anchor will still work. But the truth of the fact is, should anything happen, we've broken the specification because we haven't provided the anchor that was specified, it hasn't been installed correctly, And worst of all, if we've changed the anchor that's been specified, we haven't followed the correct change management process. And this is important, again, not because of failure, but because the ability to prove your install. If we install the anchors that you've specified, if we install them correctly, then we can realise the recommended loads of those anchors. Without proof that the anchor's been selected right and installed right, you won't realise the recommended load of that anchor, which is the proof. The install is the biggest variable in all of this. The installer is 9 times out of 10 the main reason why installations, both anchors and bracketry, actually fail. It's a lack of understanding of the fundamental basics of that particular type of anchor. And BS 8539 again helps us out with this. It's training and a bit more training. There's 2 types of training, installer training and supervisor training. Installer training, in essence, is the easiest bit. We can capture that in one simple sentence. Install the anchor to the manufacturer's instructions. An ETA approved anchor will have all the information on the box required to install that anchor correctly. It will give you the drill, diameter and depth. It will tell you 9 times out of 10 to clean the hole out. It will give you the setting tool requirements for that anchor. It will tell you the torque requirements for that anchor. And torque is a really important and critical term here, and we will have a further slide on torque, but just keep it in the back of your mind. And it will also tell you the loads that that particular anchor can take. But for the installer, the instructions are on the box. The drill, diameter and depth as mentioned, how to install the anchor, clean the hole out, the setting tools that are required. It's all on the box. But training is absolutely everything. Now, as a worst case scenario, a toolbox torque is better than nothing. So whoever anchor you've chosen to specify, get your installation teams trained on how to install them. There's an estimate out there that for drop-in anchors that over 80% are actually installed incorrectly. Personally, I think that figure is wrong. It's more like 95% are installed incorrectly for a couple of good reasons. First and foremost, the correct setting tool is not used. Most people will use a generic setting tool. Well, there isn't a generic setting tool for drop-in anchors. They are manufacturer and size dependent. And the other bit, and again, this is required to be able to evidence and release the load data, even for a drop-in anchor, on the installation instructions, an ETA approved one will tell you a maximum torque. Well, why do we need a torque for a drop-in anchor when they are controlled by striking with a hammer a setting tool? Well, the torque is there for the set screw or the locking nut that we apply to that anchor, and you'll find it's quite a low torque on most manufacturers' most manufacturers' set screws. If we over torque them, in essence what we're doing is we are pulling the anchor out of the substrate, and therefore we're not realising the full load that that anchor can actually take. Obviously for a through bolt the torque is critical. The torque will control the setting of the anchor, and also after load relaxation it will ensure that the fixture doesn't move because the correct torque has been applied. And for concrete screws, which are thankfully quite a common anchor in the M&E industry now, torque is critical there as well. The installation torque needs to be adhered to. So on the box of ETA approved concrete screws, you will find an installation torque. The installers need to understand that their impact tools need to be rated at that torque value or under, so that the anchor isn't over torqued when installed into the substrate. So training is critical. We've evolved the toolbox torque into more of an online facility here at Midfix, so we can give you the awareness to the end installers via a remote facility on how to install anchors. Probably the most important part of training though is the supervisor. The supervisor is the control point for all that happens within BS 8539 for anchors and for bracketry, which we'll come up to. Within BS 8539, the supervisor has their own section and they have their own responsibilities. So the supervisor is typically a senior member of the site team. It could be a project manager or akin to that. They're responsible for a number of key areas. First and foremost, this is where it all comes together. The supervisor is there to ensure that the specified anchor is the anchor that is being installed, or that the correct change management process has taken place. The supervisor's responsibility is to make sure that the installation teams have the required setting tools. The supervisor also has the responsibility to ensure that the installers are trained in the installation of that particular make of anchor. And finally, the supervisor should be signing off the installation prior to it being loaded to say that those 3 previous points have been adhered to. Because the supervisor cannot witness every install, they need to ensure that it's the correct anchor, they have the correct setting tools, which will include a torque wrench 9 times out of 10, and that the installers are trained. This again is part of the evidence required to be able to prove that you've installed the anchors correctly and that they will take the service load or the recommended load that the anchors have been published with. We need to be able to evidence 2 things here. It's the correct anchor and it's been installed correctly. And finally, well, not finally, but part of the training process is the supervisor needs to understand that that installer is trained, is aware of how to install the anchor. We do it with an online certificate facility via the Midfix Academy. But the supervisor needs to capture that information, and that's part of your evidence. So your ETA data sheet and all the due diligence for the product is held, and the training certs for the installation teams to prove they are aware of how to install that anchor are also held. Those 2 bits of information give you your compliant installation, and it releases the full load information for that anchor. Finally, the testing. We often get asked to carry out testing on site. It's normally called a pull test. It's not the correct terminology, but that's how the industry recognises it, as a pull test. BS 8539 actually tells us that if we've installed an ETA approved anchor into a known substrate and it's done under trained supervision, i.e. the supervisor, with trained installers, there is absolutely no need to carry out a proof test. And that makes quite a lot of sense if you think about it. The anchor has gone through a very expensive and rigorous ETA process. There is no way that that testing process can be replicated on site. So a proof test isn't required, but normally one of those elements is missing. Either the training competencies of the installation teams or the supervisor. The substrate might be unknown as well. If we don't know the design strength, then we have to carry out testing. But there's 2 types of testing. There's a proof test, which is probably the most common type of testing. This is when we attend site to anchors that are already installed and we just prove their installation. That's all it does. It proves it's been installed and it reaches a test load. It doesn't actually tell us that the anchor's been selected correctly in the first place, but it does prove it's been installed and it does reach a test load. Normally that test load is only 1.5 times a recommended load, and there's a reason for that. It's because that anchor is being left in service. If we go above the design load, then we need to remove that anchor from service. But a proof test is just a test that proves this anchor in this particular application has been installed correctly. If there's an element of the ETA that's missing, then we need to carry out allowable load testing. Just move on to that one. Allowable load testing is a little bit more rigorous. It requires a different type of card for the operator to carry. One thing to bear in mind, anybody carrying out testing for you or on your behalf needs to hold a CFA, Constructions Fixing Association, tester card. A general card is required for proof testing, and an advanced card is required for allowable load testing. But allowable load testing is only specific for that particular site, that particular fixing. It's usually for when we have an element of the ETA missing, such as it's an old building and we don't know the design strength. We then carry out allowable load testing to find out the suitability of that anchor in that application only. Whereas an ETA in a known substrate can be transferred from site to site. allowable load testing is fixed on that particular application. And if the substrates vary, we may have to carry out more than 1 or 2 allowable load tests. So that's testing. We've broken it down, BS 8539, into the selection process. Don't forget, whoever makes that selection is the specifier, and they're the first port of call should something go wrong. The supply of that, and a lot of the times, whoever's changing that supply, for whatever reason, could be commercial, it could be availability, they've become the specifier if they change that anchor. The install, the biggest variable, that's where it's going to go wrong. That's where issues occur. Anchors themselves very, very rarely fail. Things come down a lot of the time. It's because they've been installed incorrectly, or they were selected wrong in the first place, which means they're not given the opportunity to perform. But the vast majority of the time, they've not been installed correctly. And some of that is down to the value we place behind anchors. Because they are a commodity item, there's not much thought gone into it. If there's not much thought gone into the selection process, it usually means there's very little, if any, thought in the installation process. But anchors are installation critical. And finally, the testing. Just bear the testing in mind. Proof testing only tells you that that anchor has been installed correctly. It doesn't tell you anything else. We then need to apply the same principles to the bracketry that's under the anchor, that the anchor's supporting, because the bracketry is carrying the same load that it's actually transferring that load to the anchor. And how do we carry out this proof? How do we evidence that the bracket is capable of taking that actual same service load? Well, that's to use a tested channel system. There are a number on the market, but a tested channel system, as the word describes, is a system that when all the components have been put together, they have been tested and they are provable. So if we look at the image on the screen, you'll see the load bearer, i.e. the channel. You'll see the loads that the channel can actually support safely. Like anchors, there is a safe working load applied to these as well. But normally, this is your next weakest point. You will see deflection occurring on site quite regularly because the channel itself has been overloaded. But this is only one point. If the channel can take a load, let's say a point load, a worst case point load of, let's pick 100 kilos, we need to understand that any joint connection can also take that load or more. So a tested system is critical. When we procure channel from just a channel supplier, 9 times out of 10 we are given a load table with that as well. But the channel itself, the load bearer, is tested as a simple beam. So the maximum deflection they give you is tested on 2 rollers with a deflection applied. It's not tested with any form of connection. As soon as we've connected to that piece of channel with either a channel-to-channel connection or a threaded rod connection to the channel, that load data is lost. And it's quite clear why. The manufacturers of that channel cannot possibly test for all end applications. And it's why, and this is where a tested channel system comes into its own, because the connections are actually provable as well. So if we look at the image now, typically a lot of the time we work with trapeze brackets to carry the services around buildings, whether that's on threaded rod or channel. And obviously the channel trapeze there, if you invert that, you've got a goalpost. The same rules apply. But every connection on that trapeze needs to be provable. That's including the tensile load on the threaded rod. The threaded rod connection to the channel needs to be able to be provable as well. Otherwise, the load data for the actual channel itself is null and void. And you can see now that the connection details are hugely important. The key thing to focus on this particular image is the little hexagon that gives you the torque value. And this applies to all tested channel systems. Just like the anchor, installation is critical. The installation teams have to be trained how to put together a tested channel system in order to do 2 things. First and foremost, release the load data, and secondly, release any warranty behind it. That joint has to be built correctly, which is where torque comes into it. And again, I will reiterate, this is for any tested channel system. That joint has to be repeatable. In order to do that, it's got to be built correctly. In order to do that, it needs an installer with a torque wrench to build it as per the manufacturer's instructions, and that will release the load and the warranty. But the training behind it is as critical as the training behind the anchors. You've selected a tested channel system. Don't miss out training the installers. That's your final piece of the jigsaw. That closes the circle and proves that you've used the tested channel system, which means you can evidence the load. And finally, they've been installed by people who are aware of how to make that connection. That releases the data. And you can see an image there of a humble 1-all bracket. If it is torqued correctly, it will achieve a load in slip and in tension, if it's been built correctly. Same as cantilever arms. Cantilever arms with a tested system will show you a uniform load, a centre point, and then a worst case fulcrum load. So your site teams have all the information required not to overload that particular cantilever arm or the channel length. And as mentioned before, it does release one of two things when being built correctly. Most importantly, it releases that load information. So you know window brackets, when we've done it correctly and we've installed 2 window brackets, torqued to the correct torque on the cone point, it will release a 200 kg load. But it's got to be built correctly. And finally, it will release any warranty behind that tested channel system. The product and the individual carrying out the install, both of these need to come together. And that's my final point, the torque wrench. This should be a standard staple diet with any installer in the building services industry for anchors and for bracketry. Without a torque wrench, we can't install a through bolt. Without a torque wrench, we can't connect to a drop-in anchor. Without understanding the torque requirements of a concrete screw, we can't install it correctly. Without a torque wrench, we can't build a repeatable, provable joint on a tested channel system. They're not expensive, but they're part of a training package. Traditionally, we've never used them in our industry. Moving forward, where the evidence is required, we will have to use them in our industry. It's the evidence that's required. The product and the individual. Bring these two items both together, and that gives us our golden thread of information to say the bracket and the fixings that I've just installed are capable of taking the service load that we've just applied. So I've sped through it fairly quickly. I'll just check that any questions have come through, and I think we do have some questions. So on that note, I will just put my glasses on and have a look at some of the questions to see if we can start answering them. So we've got one here. Would you need a register if you like to stop wood? That's quite a complex one come through from James. Change order control. Do you need a register? So when we're looking at change management, this is, as mentioned earlier in the process, an area where it does tend to go wrong. Most of the time in our industry, change management is not logged and it's done for the wrong reasons. It's done for either the specified anchor is not available from your chosen supplier, or the specified anchor is quite expensive and you know you can get an equivalent anchor much cheaper. Change management doesn't preclude change, it just makes it important to control the change and make sure it is logged. So to answer your question, James, yes, it does need logging, and the original specifier does need to be told of that particular change. Just look at a couple more that we have. Another one here, would you ever consider bolting through the slab and plating the other side of the bolt? I think I understand your question, if I understand it correctly. Sometimes that is required. The only downside of that is being able to actually evidence and prove that particular connection. That could be quite tricky. My question to that would be, why are we considering that? We would need to look into that one a little bit deeper, but yes, it might need to be looked at. The difficulty is going to be, because it's a bespoke solution, is actually going to be evidencing and proving that particular connection. Bear with me. Let's have a quick look. I think that's all we've got for now. I think it's worth pointing out that you can actually post questions if you're going to be viewing this later via YouTube. You can actually still post your questions then, and we will come back to you because we've got your information tracked. We'll be able to ping you back a message. But many thanks for joining. I hope you've enjoyed it. I hope you've picked something up. It is the first live event for us. We would like to be doing a few more in the near future. But the key takeaways from this really are a couple of points. First and foremost, the product itself, make sure that is fit for the purpose. And secondly, the installer, make sure they are trained. I've just been told we've had one more question come through just before we go. Let's have a quick look. Is there a test standards for channel? That's a really good question. So you'll notice on most channel there will be a BS stamp on the side of it. That BS stamp is quite important. It gives us some basic information. It gives us the information such as the channel slot patterns, orientation. It gives us dimensional information on the channel, the gauges. So the BS standards actually apply to 2.5mm and 1.5mm gauge channel, but it doesn't give performance data for channel. The performance data for channel is actually given from using a tested channel system, as mentioned earlier. And it's actually a point that was raised in the Hackett report from Dame Judith Hackett. One of the criticisms was mixing and matching products in our industry. And as mentioned before, once we have two products, dissimilar products from different manufacturers, both tested, as soon as they're put together, we lose that test information because quite clearly manufacturers can't test with other manufacturers' products. So it's very important to use a tested system. But to answer your question, yes, a tested channel system will give you the full load data for not only the load bearer of the channel, but for the individual joints and drops such as the threaded rod in that particular suspension. And I think that is our last question. Thank you for that. Again, thank you all. Mentioned before, hope you've took something from it. Please feel free to drop the questions through as and when you think of them. And we'll see you at our next live event. Thank you.